Yeah, today we'll discuss about the logic gates. Okay, logic gates. If you see, first is the NOT gate. NOT gate. So, what is this NOT gate means? Complement of input is nothing but NOT gate. Complement of input. Okay, and AND gate. AND gate. Any one of the input is low. Any one of the input is low. The output is low. Okay, and OR gate. Any input is any one of the input input is high, the output is high. The output is high. And NAND gate, NAND gate. Any one of the input is any one of the input is high, the output is high. The output is high. Okay. Any one of the input is sorry. Any one of the input is low. Okay. Any one of the input is low, the output is high. NOR gate, NOR gate. Any one of the input is high, the output is low. Any one of the input is high, the output is low. The output is low. XOR gate. XOR gate is nothing but odd number of inputs, the output is high. Odd number of inputs. It's like an odd detector only. Odd number of inputs, the output is high. The output is high. And next, XNOR gate. XNOR gate, even number of inputs, the output is high. Output is high. Okay. So we'll see each and every gate in detail. Okay. Okay. So first we'll see about the logic gates. First gate is NOT gate. NOT gate. So NOT gate, if you see, this is the symbol for NOT gate. So this is input is A, Y equal to A bar. And coming to the truth table, truth table A and output Y. Input is 0, output is 1. Input is 1, output is 0. This is NOT gate. Complement of input is nothing but output. Okay. And next, buffer. Buffer. Buffer means whatever the input you are giving, you are getting the output. Y equal to A. Okay. So if you see the truth table, A and Y. So 0 means 0, 1 means 1. Same thing. Okay. So whatever input you are giving, you are getting the output. Okay. And next, OR gate. OR gate, if you see, this is the symbol for OR gate. So A, B, and Y equal to ARB. Y equal to ARB. Okay. A, B, and output is Y. If any one of the input, so combinations are 0, 0, 0, 1, 1, 0, 1, 1, 1, 1. Yeah. So if any one of the input is high, the output is high. Okay. Next, AND gate. AND gate. So if you see the AND gate, this is the symbol for AND gate. A, B, Y equal to A and B. Y equal to A and B. Okay. So A, B, and output is y. If input any one of the input is low, the output is low. 1. Okay. This is NAND gate. Okay. Coming to the NOR gate. Okay. Coming to the NOR gate. Here I am drawing the NOR gate. Okay. I will see in the next page. Next NAND gate. NAND gate. NAND gate, if you see, this is the symbol for NAND gate. AND gate followed by a bubble. So this is A, B, and output Y equal to what? AB bar. Output Y equal to AB bar. So if you see the truth table, so here A, B, and output Y. So 0, 0, 0, 1, 1, 0, 1, 1, 1, 1, 1. Just any one of the input is low, the output is high, and 0. Okay. And NOR gate, if you see, this is the symbol for NOR gate. A, B, and output Y equal to ARB whole bar. So if you see the truth table, A, B, output is Y, 0, 0, 0, 1, 1, 0, 1, 1. Any one of the input is high, the output is low. Both inputs are low, the output is high. This is NOR gate. Okay. And coming to the XOR gate. So this is the XOR gate. A, B, and Y equal to A XOR B. This is equal to A bar B plus AB bar. A bar B plus AB bar. So if you see the truth table, A, B, and output Y, 0, 0, 0, 1, 1, 0, 1, 1. For odd number of inputs, the output is 1. For even number of input, the output is 0. Okay. And next, XNOR gate. XNOR gate. XNOR gate, if you see, so this is the XOR gate followed by a bubble A and B. Y equal to A XNOR B. So the expression is A bar B bar plus AB. A bar B bar plus AB. Or you can write as A XOR B whole bar. A XOR B whole bar. So for even number of inputs, the output is even number of inputs. Inputs are same. The output is high. 0, 0, 0, 1, 1, 0, 1, 1. This is the 1. This is 1 and 0, 0. Do you understood the logic gates? Next, coming to the NOT gate. NOT gate. So how to implement the NOT gate by using NAND gate? NAND gate, there are two representations are there. One representation is where inputs are tied together and you are giving to one NAND gate. So this is A and A whole bar. A and A equal to what? A, no? This is A bar. A bar. Okay. And second representation is one input is given to NAND gate and other input is given to logic 1. Okay. A and 1 whole bar equal to what? A bar. Okay. This is NAND realization. Suppose coming to NOR, first representation is inputs are tied together given to one NOR gate. So A or A whole bar. This is equal to what? A bar, no? And one input is given to NOR gate A and other input is given to logic 0. So A or 0 whole bar equal to A bar. Okay. Next you have equivalency of gates. Equivalency. Okay. Equivalent gates. Equivalent gates, if you see, you know the De Morgan's law. AB whole bar equal to A bar plus B bar. A bar plus B bar. So that means NAND gate is equal to bubbled OR. NAND gate. NAND gate is equivalent to, this is NAND gate AB and Y equal to AB bar. This is equivalent to bubbled OR. Bubbled OR AB. Okay. Y equal to, this is A bar plus B bar. Okay. And one more debar slide there. That is ARB whole bar equal to A bar and B bar. This we'll discuss in the Boolean algebra. NOR gate is equivalent to bubbled and so NOR gate, this is NOR gate A B Y equal to ARB whole bar. This is equivalent to bubbled and, okay, A B. Okay, and if it is a wire is there, suppose this is wire. Okay, wire means A. So how to represent two inverters connected in cascade? Here you are getting A bar whole bar equal to what? A. Do you understood how we are doing equivalent gates? A bar whole bar. A bar complement of complement is true form. Complement of complement, you are getting true form only. Why? Because suppose example you take 0 bar whole bar. 0 bar equal to what? 1. 1 bar equal to what? 0. You are getting. Okay. Similarly, 1 bar whole bar is there. So 1 bar is 0. 0 bar. This is equal to what? You are getting 1. Okay. Next, we need to implementation using only NAND gate. Only NAND gate. How to implement by using only NAND gate means you need to apply. You need to follow this step. Okay. So write the function. Function in the sum of products. Sum of product. SOP form. Okay. Sum of products. And next, draw using basic gates. And next, for the AND gate, a bubble is added at the output side. A bubble at the output side, and for the OR gate, add bubble. Okay, add bubble, bubbles at the input side. To compensate added bubble, to compensate for added bubble, mm, add an inverter. Okay, add an inverter. Any inverters are said to be in series, remove both of them. Any two inverters are in series, remove both of them. Okay, and replace any remaining gates any remaining gates, and inverters with equivalent NAND gate, NAND gate. Okay, NAND implementation. These are the steps you need to follow when you implement by using NAND gate. First, write the function in the sum of product form, draw using basic gates. Wherever the AND gate is there, you need to add the bubble at the output side. Wherever the OR gate is there, you need to add the bubble at the input side. To compensate for added bubbles, add an inverter. So any two inverters are in series, remove both of them and replace any remaining gates and inverter with equivalent NAND gate. Okay. So suppose inverter is there. Suppose inverter is there. So inverter we already implemented. So that means this is equivalent to what inputs tied together connected with the NAND gate. Okay, y equal to a and a whole bar. This is equal to a bar. Okay, this is over. Suppose the AND gate. This is NOT gate and AND gate is there. AND gate. This is the AND gate. So wherever the AND gates are there, you need to add the bubble at where output no. Wherever the AND gate is there, see here. For AND gate, you need to add the bubble at the output side. For OR gate, you need to add the bubble at the input side. Okay. So that means here you are added the bubble at the output side. Okay. Next, wherever you added the bubble, to compensate the added bubble, you need to add an inverter. Okay. So here next step what you need to do for this added bubble, you need to add the inverter. Okay. You need to add the inverter. Again, replace all gates with NAND gates. That means this is NAND gate and this is given to one more inverter is replaced with NAND gate. See here, this is AB. Here you are getting AB whole bar. So AB whole bar. This is equal to what AB now? AB. Okay. This is the AND gate. And coming to the OR gate. OR gate. First you draw the OR gate. So wherever OR gate are there, you need to add the bubble at the input. No? Input. Yeah, input you need to add. And next, wherever you added the bubble, you need to add the inverter. And again replace this with all NAND gates. So this is one NAND gate. This is one more NAND gate. And this input is given to bubbled R equal to what NAND gate now? Bubbled R equal to what NAND gate? We already seen equivalency of gates where we have seen somewhere equivalency of gates. Okay. The bubbled and equal to. So this is A and this is B. Here you are getting A bar and this is B bar. A bar and B bar whole bar. Whole bar. Apply demarcans na. A bar whole bar plus B bar whole bar. This is ARB no. OR gate you got okay. And a NOR gate, how you get NOR gate means from here when you apply one more inverter connected with NAND gate, here this is nothing but ARB whole bar. NOR gate. Here you will get NOR gate. NOR gate. NAND means you are realizing by using NAND only, no? Okay. These are nothing but universal gates. Universal gates means you can get any of the gate you can get any of the combinational circuit by using these gates. That's why we call as universal gates. NAND and NOR are universal gates. NOR. Okay. Coming to the XOR gate. XOR gate. XOR gate, first you draw the XOR gate. So this is my XOR gate. So A, B, Y equal to A XOR B. So this is the A bar B plus AB bar. Okay. Now draw normally. Like A bar B means what? A bar means so connected with an inverter, and B connected with an AND gate, and again A and B is connected with an inverter and connected with an AND gate, and this is connected with the OR gate. Okay. So this is B, A, B. Okay. What is the next step? This is step 1. Second step. Wherever the AND gate is there, you need to add the bubble at the output. And here also, you need to add the bubble at the output. Output, output. Again, wherever the OR gate are there, you need to add the bubble at the input. Okay. And next, so no need to add the inverters. Why? Because here you added the bubble. Here you added bubble. Two inverters means both will cancel. No need to add the inverter. Why? Because if you add one inverter, here if you add one inverter, both will cancel. No need to add inverter. Okay. Again, replace with NAND gate. All the gates with NAND gate. So here this is one NAND gate, and this one NAND gate, and bubbled are equal to what? NAND gate, no? NAND gate. Okay. So here this is A and B, A and B. Okay. So I can rearrange and I can draw the circuit like this. Suppose I will combine these two NAND gates and I will give to one NAND gate. See here A and here B. This is given to, these inputs are taken and given to one NAND gate. Okay. Again, and next so this NAND gate equal to, I combine these two NAND gates, I got one NAND gate. Okay. And again one NAND gate here, this NAND gate, and this is one more NAND gate, and this is given to one more NAND gate. Okay. So if you realize so whether I am getting XOR gate or not, just will see. This is the AB whole bar. Okay. AB whole bar, and next so here you can write, one second. Here you can write this one as A bar plus B bar. Okay. This one A and A bar plus B bar whole bar. Can I write whole bar? Whole bar. Okay. A is one input. Another input is A bar plus B bar whole bar. So this is A bar, A and A bar plus AB bar. Okay, whole bar. A and A bar equal to what? 0, no? 0 plus AB bar whole bar. So here you are getting AB bar whole bar. Similarly, here you will get A bar B whole bar. Okay. So again it is given to one more NAND gate, AB bar whole bar and A bar B whole bar whole bar. So here you are applying De Morgan's law. AB bar whole bar plus A bar B whole bar whole bar. So complement of complement is true form. AB bar plus A bar B. This is equal to A XOR. XOR gate you got, no? How you will get XNOR gate? This output is there, no? This output again you will give it to one more NAND gate. NAND gate. Here you are getting A XOR B whole bar. This is equal to A XOR B. A XNOR. Okay. So how we are getting this here? So if you take this, so A XOR B whole bar. Okay. So this is the A bar B plus A B bar whole bar. Apply De Morgan's law. What you are getting? A bar B whole bar. A B bar whole bar. No. This is A bar whole bar plus B bar. Again A bar plus B bar whole bar. So this you will get A or B bar or A bar plus B. Okay, this is you can write as A and A bar plus AB plus A bar B bar plus B bar B. Anyway, this is 0, this is 0. Okay, this is equal to A bar B bar plus AB. So this is equal to A and B, A XOR B, A XOR B. So I implemented all the gates with this one, no? Okay, okay. Suppose let us take one expression is there. A bar plus BC bar is there. Can you realize by using NAND gate? Or should I explain? This one you need to realize by using NAND gate. First you will see. First you need to draw with the normal NAND gate. Okay. Okay. So this is the B and this is the C bar and here this is the AND gate and followed by OR gate. OR gate. Normal AOI logic I draw. Okay. This is ABC. Okay. Okay. This is step 1. What is step 2? Yeah, you need to add the bubble at the output of AND gate and add the bubble at the input of OR gate. So here this. So this is the AND gate. I'm adding the bubble at the output of this one, and here you are adding the bubble at the input of OR gate. Okay. So after that, wherever you added the bubble, you need to add the inverter. Okay. Here. So here this is you added a bubble. You need to add the inverter, and here also you need to add the inverter, and this is given to bubbled R. Bubbled R. Okay. And so inverters are in cascade. You need to delete. Okay. You need to eliminate. Okay. Now what happens? What is the circuit you are getting? This is A. Directly it is given and here this is inverter, NAND gate and again bubbled R. Okay, BC. Okay. Again replace all the gates with the respective NAND gate. Bubbled R equal to NAND gate, and here this is one more NAND gate, and here this one is one more NAND gate, and this is given to NAND. So A, B, C. Like this you need to implement. Suppose if you see here, so whether I am getting, you need to check whether you are getting this expression or not. So this is C bar, and this is the B C bar whole bar. Okay, and this one is A and B C bar whole bar. So this is equal to A bar plus B C bar whole bar whole bar. So this is A bar plus B C bar. Both are same, no? Okay. Yeah. Next, implementation by using NOR gate. Implementation by using NOR gate. Only NOR gate. How to implement by using NOR gate? So first, write the logic function. Write the logic function and draw the basic gates. Draw the basic gates. Okay. And for OR gate, for OR gates, for OR gate, add add bubble at input side, bubble at input side, and for AND gate, for AND gate, add bubble at bubble at 1 second. For OR gate, oh sorry, for OR gate you need to add the bubble at the output side. For OR gate you need to add the bubble at the output side. For AND gate you need to add the bubble at the input side. Input side. Okay. And next, to compensate added bubble, compensate the added bubble, add an inverter, add an inverter. Okay. And any two inverters are connected in series, remove both of them. Any two inverters inverters are in series, remove them, remove both of them. Okay. And next, replace remaining gates, replace remaining gates, remaining gates, and inverters with the equivalent NOR gate, with the equivalent NOR gate, NOR implementation. Okay. So we'll see the basic logic gates, how to implement basic logic gates. First, NOR gate. Sorry, first NOT gate. First NOT gate. How to implement NOT gate? NOT gate. How to implement? So we already see inverter A, and here output is A bar, and these inputs are tied together. No, A whole bar. This is equal to A bar. Okay, and next, OR gate. This is the symbol for OR gate. Okay, A, B, Y equal to what? A or B. A plus B. Wherever the OR gate is there, you need to add the bubble at the output side. No, output side. Okay. So Y equal to next. Next, wherever you added the bubble, you need to add the inverter. No. Okay. So you need to add the inverter. So here this you need to add the inverter. So this is A, B. Okay. And next, replace all the gates with the respective NOR gates. This is NOR gate and inputs. This is inverter. Input tied together. This is NOR gate. A, B, ARB whole bar. So this is ARB whole bar whole bar. This is ARB. You got alternate OR gate? Okay. And next, AND gate. AND gate. First you draw the AND gate. This is my AND gate. Uh, for the AND gate, you need to add the bubble at the input side, no? Input side. Okay. Next, wherever you added the bubble, you need to add the inverter. bubbled and gate, and replace all gates with respect to NOR gate, NOR gate, NOR gate. This is one NOR gate, and the inputs are tied to inputs given to bubbled and equal to NOR gate, bubbled and equal to NOR gate. This is A, B, this is A bar, and this is B bar, A bar, or B bar, whole bar. This is A bar, whole bar, and B bar, whole bar. So this is equal to A. AND gate you got, no? Same thing. Yeah. Gate is different. Yes. Suppose XR gate is there. XR gate. So this is A, B, Y equal to what? A XR B. So this you can write as A bar B plus AB bar. Okay. Now normally you draw the logic diagram. So this is A given to the inverter, B, this is A and B, and one more A, B is given through the inverter, and this output as given to NAND gate, OR gate. Okay, A, B. Okay, and next, what is the next step? Wherever the AND gates are there, input side, input side, and here also you need to add the bubble at the input side, input side, and next OR gate, you need to add the bubble at the output side. Okay, wherever you added the bubble, you need to inverter. Yeah, you need to add the inverter, and here also I am adding the inverter, and this is bubbled and here also you need to add the inverter, and here also you need to add the inverter, and this one add the inverter, and this output here also you add the inverter. So two inverters are there, need to cancel each other. Okay, which one? A B and A B. Here you added the bubble now. Wherever you added the bubble, you need to add the inverter. That's why here also you need to add the inverter. Here inverter, here inverter, here inverter. Okay. And next, what you need to do? So like this, you will get the circuit. Mm, okay. One second. Here you need to add the inverter. You are asking here, no? Yeah. Here you need to add the inverter. Yeah. Next, this one inverter and connected with the bubbled and next inverter bubbled and this is given to NOR gate and inverter. Now replace all the gates with NOR gates. Okay, so this is one by NOR gate and one more NOR gate here, one more NOR gate, and here also one more NOR gate, and this is given to one more NOR gate. The output is given to one more NOR gate, and next this is given to one more NOR gate, one more NOR gate. Okay. So here A, B, A, B, B. Okay. So I can rearrange this gate like this. How I can rearrange? Here two inputs are there, A, B. Okay. These two NOR gates are there. No, I'm combining with one NOR gate. One NOR gate. So one NOR gate. This is one NOR gate, and next these are the two NOR gates. These are the two NOR gates, and this input is given to one more NOR gate and one more NOR gate. So see here, suppose this is ARB whole bar. This you can write as A bar and B bar. B bar. Okay. This is A bar, B bar, whole bar. You have some absorption that we'll discuss in Boolean algebra. A or A bar B equal to A or B. True form, complemented form. This will be redundant. This will be eliminated. Okay. So this you can write as what? A or B bar, whole bar. Okay. A or B bar, whole bar. So this apply De Morgan's law. A bar, B bar, whole bar. Okay. This is A bar B. Similarly, if you write here AB bar, AB bar, okay, AB bar, and here what you are getting A bar B plus AB bar whole bar. So that means A XOR B whole bar, okay. A XOR B whole bar equal to XNOR. No? Here itself you got XNOR, XNOR gate, okay, XNOR, this XNOR gate, this XNOR gate, AB, okay, Y equal to A XNOR B, and A XOR B whole bar equal to what? XOR. Here you will get XOR gate. Why XOR gate? XOR gate. So how many NOR gates are required to implement XOR gate? How many NOR gates are required to implement XNOR gate? 4. Here you see. How many NAND gates are required to implement XOR gate? Where we are seeing C. 4 NOR gates. Okay. To implement XNOR gate? 5. Yeah. Okay. Suppose same expression is there. So I want to implement by using NOR gate. Same expression I will take. Y equal to what? A Boolean expression. Y equal to A bar plus BC bar. Okay. Y equal to A bar plus BC bar. I want to implement. So how to implement? First you draw normally. So this is A, and here B connected with an inverter, and this is AND gate, and these all are given to NOR, OR gate, yeah, OR gate, A, B, and C. Wherever the OR gates are there, wherever the AND gate is there, you need to add the bubble at the input. Input. And wherever the OR gates are there, you need to add the bubble at the output. Output. Okay. And wherever you added the bubble, you need to add the inverter. Okay. So here this is here you need to add the inverter, and here also you need to add the inverter. Again one more inverter, and bubbled and next this one is given to where first one I added inverter. Here for this bubble I added inverter. Already inverter is there, no? This is already inverter is there. Okay, this is inverter. Okay, and both are in cascade. You need to cancel. Okay, and here this one. So like this you will get. So bubbled and next this one NOR gate and next OR gate. Okay, and replace all gates with the respective NOR gates. So here one more NOR gate, and this is NOR gate, and this is NOR gate, and this is given to one more NOR gate, and this is one more. All gates should be in which normally NOR gate. Okay, A, B, C. Okay, A, B, C. Okay. Suppose if you want to implement whether my expression is correct or not, just here this is A bar and this is B bar, C. This you can write as B bar plus C, B bar plus C, and here A bar plus B bar C whole bar, no, B bar C whole bar. Okay, this is you can write as B bar whole bar or C bar. Okay, BC bar. This is BC bar. So here BC bar whole bar. So here this output is A bar plus BC bar whole bar. So you are getting A bar complement of complement is true form. A bar plus BC bar. Both are same, no? Verified. Okay. Yeah. Okay. This I will give one task. Just you do tomorrow and show me. Mm, I'll give one diagram. These steps only you follow. Implement this AOI logic and or invert logic by using NAND gate and NOR gate. Only NAND gate, only NOR gate. This one you implement.